Welcome one and all. It's time to share the third video on complex number. I have already uploaded two videos on complex number. So this is from exercise 2b. You must be knowing these four things. After that, the first question, write 4 minus 3i cube in the form a plus ib. A plus ib is the standard form of complex number. So using the formula a minus b ka cube. So this is the formula for a minus b cube. So expand by the formula. After that, I square minus 1, I cube minus I. So use all these and get the result in a plus ib form. So this is your a and this is your b. So b. So a plus ib form is ready. Now second, if z is equal to this, find z, real part of z, imaginary part of z, and modulus of z. So z is equal to root 2 minus 3 can be written as 3i square. Since I square is minus 1, so this is 1i taken outside, root 2 minus root 3i. Real part of z is root 2 itself. Imaginary part of z is minus root 3. And modulus of z according to this formula is a square plus b square, so root 5. Now, fourth and fifth both are identical question. If find the modulus and conjugate of 6 plus 5i whole square. So 6 plus 5i is expanded by a square plus 2ab plus b square. Using I square minus 1, we get 11 plus 60i. Now z is equal to 11 plus 60i. So z bar is called conjugate. Only the mid sign is changed. So 11 minus 60i. Now the modulus of z according to this formula is 3721. Now next, find the modulus of this. To find the modulus of this, let it be z. Z is equal to this into this. After that, cross multiply, and we are getting this. Now this is the fastest formula. A plus b whole square minus a minus b whole square is equal to 4ab of algebra. So 4ab by a plus b into a minus b a square minus b square. Now use I square minus 1, so it becomes plus. So 2i by 4i by 2 is 2i. This is 0 plus 2i. So then the modulus of z is 0 square plus 2 square. So this is 2 answer. Moving towards next problem. So let us see the next problem. Next problem is 7th number. If z is equal to 1 minus I. If z is equal to 1 minus I. This is z1. And z2 is equal to minus 2 plus 4i, minus 2 plus 4i, and imaginary part of z1, z2 by z1 bar. So this has to be calculated. Z1 bar you know. So first of all, get z1 bar. Simply change the mid sign. This is 1 plus I. Now move to find z1 and z2. z1 multiply z2. So this is 1 minus I multiply minus 2 plus 4i. Now multiply this. If 1 is multiplied with this as usual, minus 2 plus 4i, minus minus plus 2i minus 4i square. Now I square is equal to minus 1. So this is minus 2 plus 6i plus 4. I square minus 1. So finally this is 2 plus 6i. 2 plus 6i. Now move towards this. Now z1 z2 by z1 bar. So this is equal to 2 plus 6i. Put the value of z1 z2 and z1 bar. Z1 bar is this 1 plus I. Now rationalize it. 1 plus I. So this is a square minus b square. After that, when this is multiplied, we get 2 minus 2i. 2, 1. Sorry, student. While rationalization, the sign must be changed. So this will be minus I and minus I. So multiplying with 2 minus 2i. 2 minus 2i plus 6i 6i minus 6i square. Again use I square minus 1. So this becomes 2, and when this is composed, this is 4i plus 6 by 1 plus 1. Since I square is equal to minus 1, so this is 1. So 2 and 6 and 2 added 8 plus 4i by 2. So 2 common, 4 plus 2i by 2. So this is Z1 plus Z2. Now imaginary part of Z1, Z2 by Z1 bar. So see the imaginary part, this is 4 plus 2i. So imaginary part is this, 2. So imaginary part is 2 answer. Now moving towards the next problem. Next problem is 8th number. If 1 plus I by 1 minus I to the power m is equal to 1, find the least value, find the least positive integer of m. The m should be announced in positive integer form. So now rationalize this, 1 plus I by 1 minus I into 1 plus I, 1 plus I. So this is minus, we rationalize this plus to the power m is equal to 1. Now this is a plus b whole square. So a square plus 2ab plus b square. A plus b into a minus b, a square minus b square. So 1 square minus I square. Use I square minus 1 and minus 1. So this is 1 plus 2i minus 1 by 1 plus 1. This is cancelled. So 2i by 2. So this is simply I. Now according to question, this is 1 already given. Now according to question, I to the power m, write it m power, and m. I to the power m is equal to 1. But you know that 1 is equal to I4. So this is I4 and hence m is equal to 4 answer. So this is the least value of m. Move towards another problem. Now there are some properties. The property must be known to the students. Let me discuss property one by one. So first property, z bar is equal to z simply. The proof is very easy. Let z is equal to a plus ib, then z bar is equal to a minus ib. The conjugate of this, again z bar to the bar, again the conjugate of this is a plus ib. So this is nothing but z. So this is z proved. Now the second property, the properties are necessary to be known by the students. Second property, z bar is equal to mod z whole square. Now let us verify this or prove this. Let z is equal to a plus ib, then z bar is obviously a minus ib. The mid sign is changed. Now z bar LHS is equal to a plus ib into a minus ib. So this is a square minus I square b square. So this is a square plus b square. Since I square is equal to minus 1, now RHS is equal to mod z whole square. This is mod z, you know, a square plus b square whole square. So this is cancelled. So a square plus b square. So this property is also proved. So in the same way, there are many properties to be known by the students. Third property, z1 plus z2 bar is equal to z1 bar plus z2 bar. Similarly for minus, the bar can be distributed over the terms. Now the next is fourth, z1 by z2 bar whole bar is equal to z1 bar by z2 bar. Similarly, fifth, z1 z2 bar is equal to z1 bar into z2 bar. Similarly, there are properties of modulus. modulus of Z1 by Z2 is equal to mod Z1 by mod Z2. Similarly, modulus of, this is 7th, modulus of Z1 Z2 is equal to Z1 Z2. So these are the properties, but students remember that Z1 plus Z2 is never equal to Z1 mod Z1 plus mod Z2, and similarly for minus, remember this is not possible. So these are the properties. After that we can move towards the further problem number 18. 18 number, express 1 plus I multiply 3 plus I by 3 minus I minus 1 minus I into 3 minus I by 3 plus I, and prove it. This is 14I by 5. Prove this is equal to this. Now we are starting from the first part. The first part is 1 plus I into 3 plus I by 3 minus I. First of all we multiply this. This is 3 plus I plus 3I plus I square. Now I square is equal to minus 1. So this is 3 minus I minus 1. So this is 4 plus 4I by, and this becomes 4I. And 3 minus 1, sorry students, I square is minus 1, so this is 2 by 3 minus I. Now rationalize it. 2 plus 4I by 3 minus I. 2 plus 4I by 3 minus I. So let it be rationalized. 2 plus 4I by 3 minus I into, this is done by 3 plus I, 3 plus I. So now when multiplied we get 3 square minus I square, and the numerator will be 6 plus 14I minus 4. Minus 4, 6 plus 14I minus 4, this is 2 plus 14I by 9 plus 1. Since I square is equal to minus 1, so it becomes plus. So this is 2 plus 14I by 10. So I am taking 2 common. So this is 1 plus 7I by 10. So this is 1 plus 7I by 5. 1 plus 7I by 5. After that, the second part, students see carefully that this is conjugate of this, this is conjugate of this, this is conjugate of this. Everywhere conjugate is lying. So second part is conjugate of the first part. The conjugate of first part. Conjugate of first part. So this is 1 minus 7I by 5. Now add both. Subtract both. So the final expression, first part minus second part, minus second part. So 1 plus 7I by 5 minus 1 minus 7I by 5. So this is 1 plus 7I minus 1 plus 7I by 5. So 1 cancel. So 14I by 5 proof. So this is your RHS. The proof is ready now. Now the student, there is a big question number 19. Usually this is very important problem. This is 1 by 1 minus 2I plus 3 by 1 plus I multiply 3 plus 4I by 2 minus 4I. Write in a plus IB form. This is long question, students. So first of all, start from this 1 by 1 minus 2I, rationalize 1 plus 2I, 1 plus 2I, and see it is finally 1 by 5 plus 2 by 5I. This is a plus ib for the first part. Now the second part, this is for first part. Second part, 3 by 1 plus I. Rationalize this. 1 minus I, 1 minus I. And similarly, you can see that this is 3 by 2 minus 3 by 2i. So the second part is also expressed in a plus ib form. Now the third part is 3 plus 4i by 2 minus 4i. Again rationalize 2 plus 4i, 2 plus 4i. So after the final calculation, this becomes 1 by 2 minus 1i, 1 by 2 plus 1i. Now all are being composed. So the given expression is equal to this plus this. 1 by 5, this plus this, 1 by 5 plus 2 by 5i plus 3 by 2 minus 3 by 2i. After that, this is multiplied with this minus half plus 1i. So add this and calculate this and get the final result 1 by 4 plus 9 by 4i. So the problem is long, you are supposed to deal yourself. Rationalize all the parts and then it will be easier to compose. Now this is 20 number, z minus 5 by z plus 5 by equal to 1. If so, prove that z is a real number. Prove that z is purely real. Now earlier I suggested the property that this is mod z minus 5 by mod z plus 5 by, this is equal to 1 by 1. After that, do cross multiplication. This is z minus 5 by is equal to mod z plus 5 by. Now let z is equal to a plus ib. So we get a plus ib minus 5 by a plus ib plus 5 by. Now this is a plus I common, b minus 5 is equal to a plus I common, b plus 5. Now you know the modulus of a plus ib is equal to a square plus b square. So we are getting this a square plus b minus 5 whole square is equal to again root a square plus b plus 5 whole square. Now simplify this. So a square plus b square minus 10b plus 25 a square. Simple algebra. Root cancel. So this is b square plus 10b plus 25. Now this cancelled. So we are left with 20b is equal to 0. So b is equal to 0. B is equal to 0. Now put in this. We have considered z is equal to ib. Hence z is equal to a plus ib. Z is equal to a plus ib. So put b is equal to 0. So a plus I into 0 is equal to a purely real. So purely real is the proof. The problem is done successfully. Now this is 21. Very urgent and important problem. X plus I by q is equal to u plus ib. Prove that u by x plus b by y is equal to 4 times x square minus y square. This is very important problem, student. So just expand it. A cube plus 3 a square b plus 3 a b square plus b cube is equal to u plus ib. Expanded this, a cube plus 3a square b plus 3ab square plus b cube. Now this becomes x cube plus 3x square yi. Now I square is minus 1, so this becomes minus 3xy square. Now I cube is again minus iy cube. This is u plus iv. Equate real and imaginary part. Equate real, imaginary parts. We get. Now see the two parts are real parts. So x cube minus 3xy square. This is u. U is the real part and this is the imaginary part. So imaginary part is 3x square y minus y cube is equal to v. Now starting from LHS and putting the value u by x plus v by y. Put the value of u. This is u. X cube minus 3xy square by x plus v. 3x square y minus y cube by y. Now 1x is cancelled after taking common. So this is x square minus 3 y square plus 1y is cancelled. So 3x square minus y square. So this gives 4x square minus 4y square. So we get 4 common x square minus y square. So the problem is done successfully. This is your RHS. So thank you very much students. We will meet again in the next video. Thank you very much.